All right, so this is 2.2 for MAC 2233 Applied Calc. So for number 9, we're going to go ahead and complete the square. Now, the way that we're going to do this one, and I'm going to do it slightly different than what the textbook does. So I'm going to have 3x squared plus 9x plus 5 is equal to 0. So what I'm going to do is I'm going to subtract 5 from both sides. Then I'm going to factor out a 3 here. Now, if you remember, we're going to do this, complete the square. We're going to add b over 2 squared to both sides to create a perfect square trinomial. So, oops, this is actually a 3, not a 9. So I'm going to do 3 over 2 to the second power, which is 9 over 4. So I'm going to add 9 over 4 to both sides. X squared 3x plus 9 over 4. Now, in this case here, I have to compensate for the fact that I factor out a 3 on the left side. So the 9 over 4 on the left side is going to be multiplied by the 3. So then I have to do the same thing with the 9 over 4 on the right side. So the reason we add the b over 2 to both sides is because we end up with a perfect square trinomial, which we can factor such as that, right? So the square root of x squared is x, the 3x is positive, so that's my positive, and then the square root of 9 over 4 is just 3 over 2. So in this case here, I'm going to have 27 over 4. So this is going to be negative 20 over 4, right? Because I need a fraction. I need to have the same denominator in order to combine those two. And so this is going to be 7 over 4. It will be x plus 3 over 2 to the second power. I'm going to subtract the 7 over 4 from both sides. And so remember that it's going to be x plus k, where hk is your vertex. So my vertex here is going to be negative 3 over 2 and negative 7 over 4. So that's my vertex for that one. So number 12. So number 12, we're going to do, again, slightly different. And the reason being is because my a is a negative. So I'm going to divide everything by negative 5. And when I do that, I get x squared plus 8 over 5x minus 3 over 5 is equal to 0. Right? That's what I have there. Now, I'm going to do the same thing I did before. I'm going to take my constant. I'm going to move it over to the other side, which is going to be 3 over 5. And then I'm going to do, right, I have to divide this by 2, which is just 8 over 5 times that, which is 8 over 10, right? And so, sorry, let me do this one again. So 8 over 5 divided by 2 is the same thing as 8 over 5 times 1 over 2, 8 over 10, which is the same thing as 4/5, right? So I'm going to do 4/5 to the second power to both sides, which is 16 over 25. So I'm going to add 16 over 25 to both sides. And so the left side is going to factor into x plus 4/5 squared. And then here I have my 3/5 and I have my 6 over 25. So I need a 25, so I'm going to multiply top and bottom by 5. So I get 15 over 25 plus 16 over 25. And so this is just going to be 31 over 25. And so in this case here, so I have those. So this is going to be x plus 4 over 5 squared. And so what's going to happen in this case here is that, actually, sorry, yeah. So that's okay. So that's going to be a positive. And so my vertex in this case is going to be negative 4/5 and 31 over 25 for that particular problem. All right, what's the next one? The next one that we're going to do for this section is number 13. So number 13 is a little bit different. What they're asking us is to give the vertex, axis of symmetry, the x and y intercepts, right? So the function is y is equal to x squared plus 5x plus 6. So we can also find a vertex by doing negative b over 2a. In other words, so we're going to do negative b over 2a, and then f of negative b over 2a would be that would be my hk, if you will. So in this case, it's going to be negative 5 over 2 times 1, which is negative 5 over 2. So then the value of x of my vertex is negative 5 over 2. So the axis of symmetry is going to be the x is equal to negative 5 over 2. That's going to be like the mirror for this particular parabola. So now I'm going to go ahead and find, right, negative 5 over 2 squared plus 5, negative 5 over 2 plus 6. So I'm going to do that for number 13, right? And so when I evaluate these particular values here for number 13, all I'm going to do is just find out what is the value of y when x is equal to negative 5 over 2. And so we know here this is going to be 25 over 4 minus 25 over 2 plus 6. Right, and that's what I have so far. And then now I'm going to just go ahead and continue evaluating this in particular. So I'm going to go ahead and find out what's the next value that I have, right? And so when I do all of this, I actually end up with negative 1/4. So then my vertex is negative 5 over 2, negative 1/4 as my vertex for this particular problem. Now, the x-intercepts. The x-intercepts, what I'm going to do is I'm going to set y equal to 0, and I'm going to solve, right? So I have x squared plus 5x plus 6. Well, we know that this is going to factor out into x plus 3, x plus 2, which means that x is equal to negative 3 and x is equal to negative 2. So that's one x-intercept, and that's my other x-intercept. Now, for the y-intercept, I'm going to set x equal to 0. So y is equal to 0 squared plus 5 times 0 plus 6, which equals to 6. And so the ordered pair is 0, 6. And so that's number 13. That's how you do all those steps for number 13. All right, let's look at number 16. Number 16 is the same. So number 16 is y is equal to negative 3x squared minus 6x plus 4. And so the first thing that we're going to do for number 16 is we're going to find the vertex, right? And so here it's going to be 6 over 2 times negative 3, right? Because remember it's negative b over 2a. So it's going to be 6 over negative 6, which is negative 1. So for this particular one, I have that my x-coordinate for my vertex is going to be negative 1. And so what I'm going to do now is I'm going to find basically what's the value of y when x is equal to negative 1. So that's negative 3, negative 1 squared, minus 6 times negative 1 plus 4, which is going to give us 7. So our vertex is negative 1, 7. Our axis of symmetry is x is equal to negative 1. The next thing we're going to do is we're going to go ahead and find the x and y intercepts. So for the first one, I'm going to find the x-intercept. So it's going to be negative 3x squared minus 6x plus 4. Now, I have to use the quadratic formula. So it's going to be 6 plus or minus 6 squared times 4 times negative 3 times 4 all over 2 times negative 3. So when we do that, we end up with -1 plus or minus square root of 21 over 3. And so basically, this is going to be -1 plus or minus, and these are my two x-intercepts, if you will, for that one. Now the y-intercepts, I'm just going to go ahead and set x equal to 0. And when I do that, I'm just going to get that y is equal to 4, right? So that ordered pair there is going to be 0, 4. All right, so that's number 16. Let's look at number 19. So number 19 is just the same thing. So number 19 is f of x is equal to 2x squared minus 4x plus 5. And so the first thing that we're going to do with number 19 is, again, we're just going to go ahead and find a vertex first. Just makes life a little easier. And so x is equal to 4 over 2 times 2, which is 4 over 4, which is 1. And so for number 19, the x-coordinate of the vertex is going to be 1. So we're going to find f of 1, which is 2 times 1 squared minus 4 times 1 plus 5. And when we do that, we get 3. So our vertex is 1, 3, and the axis of symmetry is x is equal to 1. All right. So what happens now? We're going to find the x and y intercept. So if I make x equal to 0, y equal to 0, I get 0 is equal to 2x squared minus 4x plus 5. So here again, we're going to have to use a quadratic formula. I plug all my values in. I get 4 plus or minus square root of negative 24. So this means that there are no x-intercepts for that particular one. And then the y-intercept is just going to be y is equal to 5, so it's going to be 0, 5 for that one. And that's number 19. All right, let me get back here real quick so I can see what it is. All right, the next one is number 20. So I'm going to leave number 20 for you guys as extra. 21. I'm going to skip 21 because that's pretty much the same. Let me jump over to 49. All right, I'm just going to the textbook here real quick. All right, number 49. So number 49 says, exercise 4952, let C of x be the cost to produce x batches of widgets, R of x be the revenue in thousands of dollars. For each exercise, we're not going to graph them, but we're going to find the minimum break-even quantity, the maximum revenue, and the maximum profit. So for number 49, the revenue function is negative x squared plus 8x. The cost function is 2x plus 5. So the first thing is, break even is when the revenue is equal to the cost. So negative x squared plus 8x is equal to 2x plus 5, right? And that's number 49. So what we're going to do is we're going to just algebraically do this instead of graphing them. It's just, I think it just makes it a little easier. Kind of practice your algebra a little bit. So when I combine like terms, what I'm going to end up with is x squared minus 6x plus 5, which factors out into x minus 5, x minus 1 is equal to 0. So then this means x is equal to 5, or x is equal to 1, not negative 1. So then the minimum break even is 1 batch, is your break even. Now, that's part B, I believe. Part A was the graphing. Part C, the maximum revenue occurs at the vertex. So R of x is equal to negative x squared plus 8x. So x is equal to negative 8 over 2 times negative 1, which is negative 8 over negative 2, which is 4. So now I'm going to find f of 4. So f of 4 is negative 4 squared times 8 times 4, which will give us 16 or $16,000. Be careful with the units because those are always important. All right, and so part D is the profit. So the profit function is basically revenue minus the cost. So negative x squared plus 8x minus 2x plus 5 is equal to negative x squared plus 8x minus 2x minus 5, which is negative x squared plus 6x minus 5. And so here, the maximum profit occurs at the vertex, right? So then x is going to be equal to negative 6, and 2 times negative 1, so we're going to get 3. So P of 3, in this particular problem, is going to be equal to negative 3 squared plus 6 times 3 minus 5, which is going to give us 4 or $4,000 is the maximum profit. All right, that was part D. And that's number 49. All right, let's go. The next one is number 51. So I'm going to go ahead and do 51. So same thing here. The revenue function for number 51 they give us is negative 4 over 5x squared plus 10x. The cost function is 2x plus 15. And so for number 51, when we set these equal to each other, right, when we set the revenue equal to the cost to find the break even, what we end up with is 4 over 5 x squared minus 40x plus 75 is equal to 0. Oops, sorry. That's not it. It's, if I move everything to one side, hold on a second. So it's going to be 4 over 5 x squared minus 8x plus 15 is equal to 0. Now, I can go ahead and multiply everything by 5. So it's going to give me my 40x plus 75 is equal to 0. And so what's going to happen here is I can go ahead and factor this. And what it factors to is 2x minus 5, 2x minus 15 is equal to 0. So x is equal to 5 over 2, and x is equal to 15 over 2. So it's 2.5 or 7.5. So the minimum is 2.5 batches for number 51. Now the maximum revenue occurs at the vertex. So then the vertex here is just going to be, right? So it's going to be negative 10 over 2 times negative 4 over 5, which is going to give us negative 10 over negative 8 over 5. So negative 10 over 1 divided by negative 8 over 5, which is going to be negative 10 over 1 times negative 5 over 8. So then this is going to be 4, this is going to be 5. So in this case here, we're going to have basically 25 over 4, which is 6.25. So the maximum revenue occurs at R of 6.25, which is going to be 31.25, which is $31,250. Now part D is the profit function. So the profit function is the revenue minus the cost. And so when we put that all together, we're going to get negative 4 over 5 x squared plus 8x minus 15 is equal to the profit function. So in this case, x is equal to negative 8 over 2 times negative 4 over 5, which will give us 5. And so then P of 5, we plug in P of 5, we get 5 or $5,000 is the maximum. All right, that's number 51. Let's look at 52. So I'm going to leave 52 for you guys also. And let's see what else we got. Got 53 and 54. All right, so let's do 53. So 53 says the revenue of a charter bus company depends on the number of unsold seats. If the revenue is given by R of X is equal to 8,000 plus 70X minus X squared, where X is the number of unsold seats, find the maximum revenue in the number of unsold seats that corresponds to maximum revenue. Sorry. So number 53, R of X is equal to 8,000 plus 70X minus X squared. So this is going to be negative 70 over 2 times negative 1, which is 70 over 2, which is 35. So 35 is the number of unsold seats. Now R of 35, if we plug in this value, it's going to be 8,000 plus 70 times 35 minus 35 squared. That's going to give us $9,225. So then this becomes 35 seats unsold and a profit of $9,925 when 35 seats are left unsold. All right, I'm going to skip number 54, and that's the end of 2.2. Thank you.